So in this example, we're talking about static friction because we have a man just standing there. He's not moving in any direction. Now, when I think about the free body diagram for this, I'm just going to consider those two forces that are the gravity force, because gravity is going to pull down on the man, and the normal force. Now, I'm not going to put friction actually on my free body diagram, which may seem a little weird on a for friction question. However, in this case, it's static friction. It's acting in all directions, right? It's holding him in all directions to his spot. So it doesn't have a direction, so I can't really put it on the actual diagram. But this is important because this allows me to think about this relationship that the normal force is equal to the gravity force. And why is this important? Well, because gravity has an equation. I can actually calculate these forces in this case because they're equal. Remember, they're only equal when we're on a flat surface, but in this case we are. A sidewalk is considered a flat surface or assumed. So I can take his 90 and multiply it by 9.8, and I can get the force of gravity, which in this case will be 882 newtons. Now, this is important because it's also giving me the normal force at the same time. And it's asking me in this question to calculate the force of friction. Once I have that, I can now find my friction force because I have my new shiny equation. The coefficient of friction times the normal force will give me the amount of friction. All I have to do is substitute. They give me the coefficient of friction. Remember, it's mu, like a cat says, is the symbol, but that's the coefficient of friction. And I multiply it by my normal force I just calculated because it is equal to the gravity force. So this will let me calculate my force of friction. So 882 times 0.4 is 352.8. Now I am going to have to think about sig figs, and I also want to think about what this means as a number. What this means is the 352.8. The reason why the coefficient is 0.40 is it's saying 40% of my normal force is being converted into friction due to the surfaces and how slippery they are. That's what basically it's telling me. So I should be able to now finish my question off. I need newtons, and I need to think about sig figs. This 0.40, 2 sig figs. Up the 90, 9.8, up 2 sig figs. So that means before I'm done, I have to round this to 2 digits, which means I need to use scientific notation. So the 3 and 5 are good, and I move the decimal place 2 spots. And voila, I have my answer, and I can now write my therefore sentence.